This is lesson 4.2, part 2, where we're still working with discrete and continuous domains. We'll quickly review what discrete and continuous means, and then we'll look at an example for this lesson where we're identifying those discrete and continuous domains from a situation. So remember, we're talking about domains, and so those are the input values for our function, okay, or what we see on the graph as the x values. So those are all the numbers that can go into our function, the first part of our function relationship. And there's two types of domains that we've been looking at, discrete and continuous. If you remember, a discrete domain is a set of input values that consist of only certain numbers in an interval. So if I'm looking at the number line and I'm looking at just the numbers from 1 to 5, and I'm only looking at the integers there, that's 1, 2, 3, 4, and 5. Is that every number in between 1 and 5? No, because that excludes 1.1, 2.3, all of those decimal and fractional numbers in between. I'm only looking at a few numbers within that interval of 1 to 5. And so we say that's discrete because those are individual separate numbers. They're not all going together. That's different from continuous, where a continuous domain is all of the input values that consist of all the numbers in an interval. So again, if I'm looking at the numbers from 1 to 5, but you can see here the difference, I draw a line between 1 to 5, okay? I have this segment, and so that means I'm including all of the numbers, 1.1, 1.2, 2.4, 2.5, all of the numbers, no matter how small the fractional number it is, or decimal number it is, it's all of the numbers from 1 to 5. It's all together. Okay, that continues. It's an unbroken stream of numbers. Again, that's different from discrete, where they're individual or they're separate, and they're kind of broken up, right? They're kind of their own little slots or their own boxes, but continuous is all together. On a graph, we were looking at a discrete continuous like this, where discrete is the individual points on a graph and they're not connected by a line. But continuous may show points on the graph, but it's connected by a line or some sort of curve that's unbroken, that's continuous, and that's showing that it's all of the numbers on that line, not just those individual points, it's all of them. So what we'll be looking at in this part of the lesson is similar to the last part. We're going to look at a situation and determine, does this have a discrete or continuous domain? And we'll also be looking at the function that goes along with that situation and completing an input-output table, like what we've done before. We're going to keep practicing that. And so we'll do that again with this lesson and determine from that input-output table and the situation that's given to us, is this a discrete or continuous domain? And we will be looking at graphs again, but you will not be graphing yet. We'll cover that at another time. So you'll be making an input-output table and determining, is this a discrete or continuous domain. So after we look at this and kind of analyze the situation, we think about it. You're buying a number of tickets to get into a museum, and that's determining your cost, right? So is this going to be a discrete or continuous domain? Like, here's some of the domain values, 1, 2, 3, 4. Are there any other domain values? Okay. Obviously, there could be more, right? You could buy 5 tickets or 6 tickets or 7 tickets, but you have to ask yourself the question, can I buy 2.5 tickets? Can I buy 3.3 tickets? Right? Can I buy a part of a ticket? No, you can't. Okay, that's not how that works. So we would say this is a discrete domain because the number of tickets that you can buy can never be a part or a decimal or a fraction. It's always going to be a whole number. So it's not all the numbers in between 0 and 4. It's just 0, 1, 2, 3, and 4. So that is a discrete domain. All right, let's walk through another example together to kind of see how all of this goes together. All right, this is an example in your notes where we're going to be looking at a function in a situation and determine, is this discrete or continuous? Does it have a discrete or continuous domain? So in this example, it says a cereal bar contains 130 calories. Okay, a cereal bar contains 130 calories. The number C of calories, that's one of our variables, consumed is a function of the number B of bars eaten. So what that's saying is there's a relationship between the number of calories that you consume and the number of bars that you eat, which if you know anything about calories in food, that makes sense, right? The amount of chips that I eat determines how many calories I'm consuming, right? If I eat a few chips, it's different than if I eat a lot of chips. So we're going to graph the function. Again, you won't be graphing on your assignment, but we'll look at the graph and then determine is the domain discrete or continuous, and we'll also make an input-output table. Okay. If you'll notice this difference between this one and the last problem we looked at, there's no function here. So let's write out the function real quick. Again, I will give you the functions for your problem. This one just happened to not. We're not quite ready to start making functions on our own. So based off of this information that's given to us, that a cereal bar contains 130 calories, and there's a relationship between C, the calories consumed, and B's, the bars eaten, I can make this I can represent the situation like this. C, the number of calories, is equal to 130 times B. Okay? And that would be the function for this situation, because what that's saying is however many bars you eat times 130 is equal to the number of calories that you consume. Okay? Again, this will be given to you on your assignment. So let's make an input-output table, for this function. Okay, so here's a rough input-output table. We've got our domains over here. We've got our function right here. And then our outputs are calories consumed over here. And we'll also write the ordered pairs when we graph it in a second. So let's go ahead and evaluate to find each of our ranges, our calories consumed for our domains. So remember, when we're plugging in our domain values, we replace it with the variable. So we take out the b and put in 0. 130 times 0 is 0. 130 times 1 is 130. So that's how many calories you consumed after eating one candy or one cereal bar. 130 times 2 is 260. So that's how many calories you consume after eating 2 cereal bars. Let's go ahead and do 3 and 4 real quick. All right, so here's our completely filled out input-output table. I finished up finding the number of calories for each of the bars eaten over here, and then I went ahead and ran out the ordered pairs right here that will go on the graph. And so what this is showing us is that when I eat one cereal bar, I consume 130 calories. When I eat 4 cereal bars, that's 520 calories. Okay. And so we're going to graph this real quick and then again determine is this a discrete or continuous domain. All right, so here's the graph of this situation with our ordered pairs on it, right, from our function. At 0, 0, because if I eat 0 bars, that's 0 calories. If I eat 1 bar, that's 130 calories. 2 bars, 260 calories, and so on. And so when we first put the points on there, because those are the only points we're looking at, it looks like it's discrete. But let's think through the situation. Are we going to connect these points or not? Okay? With a line. Are we going to draw a line through these points or not? So if you think about the situation, you're eating cereal bars. Okay? If you eat 0, 0 calories. 1, 130 calories. 2, 260 calories. Can you eat a part of a cereal bar? Yes, you can, right? You don't have to eat the whole thing at once. So if you can eat a part of a cereal bar, could I probably figure out how many calories do I consume if I ate a half of a cereal bar? Okay? Would that be somewhere in here? How many calories would I consume if I ate 3.5 cereal bars? You know, where's that going to be? Can I figure that out? Yes, because I can eat that amount. So if I can start to figure out, okay, what would a half be? Then I could even figure out something smaller than that. What would a fourth be? Now, is it tough to, make sure you're getting exactly a fourth of a cereal bar, or even smaller, an eighth of a cereal bar? Yeah, but the idea is, in this situation, we could plug in any of these numbers into our domain. So that means I'm going to draw a line, which obviously it's not a perfectly straight line. My points aren't perfectly on it. But I can draw a line through these points because it doesn't just include these points, it includes all of the points in between. Okay? Because I can eat a part of a cereal bar. And so this domain, we would say, is continuous. This is a continuous domain because it's not just, if I don't need just 1, 2, 3, 4, 5 bars. I can need a whole bunch of different range of bars, right? And so we would say this is a continuous domain because I can eat all these different parts of a cereal bar. Now, do you eat that way? Probably not. But in this situation, we can say that there is domains other than 1, 2, 3, and 4. And so again, that's the difference between discrete and continuous. Discrete is just a few of those numbers in an interval. A continuous is all of the numbers in an interval. A discrete is individual, separate, broken up. Continuous is all together, unbroken. It's a constant, smooth curve.